Hello everyone, thank you for joining my class. I am Dr. Farida Abu Bakar from University Tun Hussein on Malaysia. And today I'm going to go through the first part of green synthesis, the way forward to the production of sustainable material. To kickstart this topic, I'm going to talk about cancer. Cancer is everywhere, literally. Every 1 to 3 women and every 1 to 2 men is suffering from cancer. Basically, according to statistics, in every 5 seconds someone dies of cancer. The question is, what happened actually? Does the medical team around the world fail tremendously to give the best service? Or us, the so-called scientists, fail to do our part? Well, some of you might say, hey, chemotherapy did wonders. Well, unfortunately, this is not always the case. Basically, cell division occurs differently in each part of our body. For example, these healthy liver cells divide only when it feels stressed. Healthy hair cells divide frequently. And the cancer cell obviously divide rapidly. Chemotherapy works by disrupting cell division. Hence, every time cell divides, it opens up itself for disruption. In other words, the more frequent the cell divide, the more likely it will be killed. Although the hair cell is not a threat, it got attacked by the drugs just because it divides frequently. But hey, hair cell is not the only cell that is in danger. Frequently dividing cells also include skin cell, gut cell, and also blood cell. These lead to the side effect of chemotherapy like hair loss, nausea, vomiting, fatigue, weight loss, and of course, pain. So what actually happened to the cancer drug in the market? Approximately over 97 to 99% of these drugs does not make it to the cancer cell. These cancer drugs do circulate in our body, but they don't have time to reach the tumor or the cancer cell. Instead, they are either being broken down and degraded in our tummy, or it will be flushed out by our body filtering system like the liver and the kidney, just like water going through sieve. Unfortunately, cancer cells are smart yet reckless. They can manipulate your body defense system and literally eat your body inside out. Therefore, drugs to cure cancer should be way smarter. Therefore, we need innovative strategies to ensure that these drugs can be transported safely to the specific tumor cell instead of being flushed out of our body system without given the chance to fight the battle. So, what can we do to improve global healthcare and further improve the quality of life? The answer is nanotechnology. If you pull one of your hair strands, and if you have thin hair like mine, and you put it under microscope, the diameter of the hair is approximately 40,000 nanometers. That should give you a rough idea of how tiny nanoparticles are. The idea is to bind the cancer drug or antibody to the nanoparticle. As explained before, cancer drugs in particular are very sensitive and easily degraded by enzymes in the blood. Unless they have nanoparticle protection, they will not be able to function well. These nanoparticles will be trained to distinguish between healthy cell and cancer cell and will further bring the drug to the exact targeted cell. For effective delivery, the nanoparticles need to be retained in the bloodstream long enough until they reach the targeted cell. Nanoparticles may also act as a specific hands with fingers that may grab only onto cancer cell, not to the neighboring healthy cell. Once it reaches the targeted cell, infrared radiation will be applied to release drug, while the rest of the body are safe from the side effect. These will cancel out the non-specific biodistribution of drug faced by the conventional drug delivery system.
Congratulations for completing the first part of the course. Prior moving on to the second part of the course, kindly click on the quiz section to test your knowledge. I wish you all the best, have fun, and see you in the next video.